Hello students. So in the previous video, we had discussed what are linear equations, isn't it? Linear equations in two variables. That is, equation is said to be linear if the highest powers of the variables involved are 1. Okay. So here we have two variables. Both the variables should have the highest power as 1. Only then we can call it as linear equation. Okay. Now, we also discuss solution, isn't it? Solution of a linear equation. Solution of a linear equation is a value which satisfies the equation. For example, if I take x plus y is equal to 5, which is a linear equation, I can tell x is equal to 2 and y is equal to 3 is a solution. Because if I substitute these values in the equation, the LHS and the RHS will become equal. So we call these values to be solution. But x equals 4 and y equals 5. Can I call it as a solution of this equation? Not possible, because if you substitute it, x will be 4 and y will be 5. So 4 plus 5 is 9. So they are not satisfying the equation. Therefore, we cannot call these as the solutions of the equation. If you observe, if you take one linear equation, that is a linear equation in two variable, you can find infinite solution, isn't it? For example, x equal to 2, y equal to 3 is a solution. X equal to 4, y is equal to 1 is a solution. X is equal to 0, y is equal to 5. Or x equal to 5, y is equal to 0 is a solution. Or x is equal to 0 0.5, y is equal to 4.5. Or let's say x is equal to 0 0.6, y is equal to 4.4. All these are solutions, isn't it? There are so many solutions that you can find. Or for example, x equals 100, y equals minus 95. You can keep doing this, isn't it? So if we considered a linear equation, only one equation, we can find infinite solutions. Okay. But if we consider pair of linear equation, so what is pair of linear equation? Two equations taken at a time simultaneously. For example, like this, x plus y is equal to 5 and x minus y is equal to 3. So this is a pair of linear equation. Okay. So for a pair, for a pair of linear equations, as we discussed in the previous video, there are three possibilities, isn't it? That is, you can have either unique solution, that is one and only one. You can have only one solution, or you can have infinitely many solution. Infinitely many solution. Infinitely many. Or you might not have solution at all, no solution. These are the things that we have discussed in the previous video. So in this video, we are going to discuss the conditions for the solvability, or the conditions for the types of solution. To get an unique solution, what is the condition? Or to get an infinite solution, what is the condition? And to get no solution, what is the condition? These are the things that we are going to discuss in this video. So let's see the conditions for solvability. Conditions for solvability. Okay. Now let's write the general form of the pair of linear equation. What is the general form of pair of linear equation? A1x plus b1y plus c1 is equal to 0. Similarly, for the second one, a2x plus b2y plus c2 is equal to 0. This is the general form, or the standard form of pair of linear equations, isn't it? Now let's see the conditions. Okay. The first condition is, let's take a1 and a2, let's divide it. That is, we are taking the ratio of a1 and a2. Okay, a1 by a2 And let's take the ratio of B1 by B2. Suppose these ratios are not equal, you will take A1 by A2. Okay, A1 and A2, we have to take the ratio, that is we have to divide it. Similarly, B1 and B2, if these values are not equal, then definitely for that pair of equations we get unique solutions. Okay, and if it is unique solution, what type of graph do we get? We get intersecting graph, isn't it? So third one is the graph, we get intersecting graph. Okay, so this is the first condition. The next condition is, suppose A1 by A2 is actually equal to B1 by B2, but it is not equal to C1 by C2. The first two are equal. A1 by A2 is equal to B1 by B2, but it is not equal to the last C1 by C2. Therefore, we will not get any solution. So no solution. If it is no solution, the graph will be parallel, isn't it? So the third one will be, if all three are equal, A1 by A2 is equal to B1 by B2, it is equal to C1 by C2. Then we get infinitely many solutions. Infinitely many solution. If it is infinitely many solution, then the graph will be coincident, isn't it? Both the graphs, that is both the straight lines, will be one top of the other, so it will be coincident. So these are the three conditions. If A1 by A2 is not equal to B1 by B2, then we get unique. The next one, if A1 by A2 and B1 by B2 are equal but not equal to C1 by C2, we don't get any solution. If all three are equal, we get infinitely many solutions. Okay, let's do some problems on this to understand better. Okay, so as you can see, I've taken three different problems. Okay, let's look into the first problem. So the first problem, they have given us a pair of linear equation. Okay, now here we have to find what type of solution do we get. Okay, so here it was 10. Okay, now the first step is to find a1, b1, c1, a2, b2, c2. So what is this? A1 coefficient of x in the first equation, b1 is coefficient of y in the first equation. This is x coefficient is 2, that is a1, y coefficient is 3, that is b1. The number without any variables, that is known as c1. Okay, so similarly in the second equation, this will be our a2, b2, c2. Okay, that's what we have written here. Okay, we have written a1, a2, b1, b2, c1, c2. Okay, now let's find a1 by a2. So a1 is 2, a2 is 3. So a1 by a2 will become 2 by 3, isn't it? Similarly, b1 by b2, b1 is 3, b2 is 5. So if you divide it, you get 3 by 5. Very clearly, 2 by 3 and 3 by 5 are not equal, isn't it? If you are getting confused, just cross multiply it. 2 5s are, you get 10, 3 3s are 9. While cross multiplying, if you are getting equal, then it will be equal. Okay, now it is not equal, isn't it? And it's very obvious, 2 by 3 and 3 by 5 both are not equal. Therefore, the condition that we have arrived is a1 by a2 is not equal to b1 by b2. Therefore, what type of solution do we get? If a1 by a2 is not equal to b1 by b2, we get unique solution. Okay, similarly, let's get into the second one. We have to find a1, b1, c1, a2, b2, c2, but we have to be very careful. If you observe in the first equation, a1 is 3, b1 is 4, c1 is minus 10, and if you observe, this c1 is in the LHS, left hand side of the equal. Okay, in the second equation, this is our a2, this is our b2, but here our c2 is in the RHS. Okay, so it will be very wrong if you take this as your c2. Remember, what you have to do is you have to get this 10 to the other side, to the LHS, then you have to find it. So what I'm trying to say is all the x, y, and the constant should be on the same side. Okay, if you observe in the first equation, minus 10 is in the LHS. Therefore, in the second equation also, the constant should be in the LHS itself. If you observe the first equation, the 5, the constant, is in the RHS. Similarly, 10 is also in the RHS. So you have to make sure both are in the same side. If they are in the LHS, both should be in the LHS, or both should be in the RHS. Okay, make sure this is done. Now, if you find the value of a1, b1, c1 and a2, b2, c2, you will get this. Okay. So here, as you can see, a1 is 3, a2 is 6. So 3 by 6 will become what? 1 by 2. Similarly, b1 by b2. b1 is 4, b2 is 8. 4 by 8, 1 by 2. Next, c1 by c2. c1 is minus 10. c2 is minus 10. So minus 10 gets cancelled. We get 1. So as you can see now, a1 by a2 and b1 by b2 are equal, but it is not equal to the third one, c1 by c2. So if this is the condition, therefore we get no solution. Okay. Similarly, let's get into the next one. Sorry. So in the next one, 5x plus 3y is equal to 9, 10x plus 6y is equal to 18. Again, the same stuff. Find a1, b1, c1, a2, b2, c2. Okay. So here a1 is 5, isn't it? b1 is 3 and c1 is 9. a2 is 10, b2 is 6 and c2 is 18. If you observe, both c1 and c2 are on the RHS, so no problem. Then as you can see, if you divide it, a1 by a2, 5 by 10 is also 1 by 2. b1 by b2, 3 by 6 is also 1 by 2. c1 by c2, 9 by 18 is also 1 by 2. If you divide everything, you're getting the same answer. Therefore, all three are equal. If all three are equal, then what type of solution we get? We get infinite solution. We get infinite solutions. Okay. I hope the logic is understood. So this is how we find what type of solution the pair has. Okay. Find a1, b1, c1, a2, b2, c2. Divide it. Okay. If a1 by a2 and b1 by b2 are not equal, unique. If both are equal, but it is not equal to the c1 by c2, then no solution. If all three are equal, then it is infinitely many solutions. Okay. So let's solve some more problems. Okay. Now, the type of problem that we're going to solve is, they'll give us a pair of linear equation or simultaneous equation, and they'll give what type of solution the pair has. Okay, here in this question, what we have done is, we are trying to find what type of solution the pair has. For example, the first question, this pair, if you take this pair, what type of solution it is having? It is having unique solution. That is what we have found out. Okay. In the next type of problem, they'll give you pair of linear equation and they'll already tell you what type of solution it has. What we have to do is, we have to find a missing value. Okay. In a1, b1, c1 and a2, b2, c2, there is some value missing. We have to find that missing value. Okay. Let's take the question. We will understand much better. So as you can see, I've taken a question, 2x plus ky is equal to 3, 3x plus 4y is equal to 10. Okay, this is a pair. Okay, this is a pair of linear equation. And what they have told us, this pair is having unique solution. It is already given. Okay, this pair is having unique solution. If it is having unique solution, find the value of k. That is the question. Okay, if the pair is having unique solution, find the value of k. So what we are going to do is the same stuff, a1, b1, c1, a2, b2, c2. a1 is 2, b1 is k, c1 is 3. Similarly, a2, b2, c2. We have already found it here. Okay. Now, since the pair has unique solution, it is given in the question itself, isn't it? Since the pair is having unique solution, we can use this condition, isn't it? a1 by a2 will not be equal to b1 by b2. If the pair is having unique solution, obviously this is the condition that is satisfied. Now substitute the value of a1. a1 is 2 divided by a2 is 3, not equal to, b1 is k and b2 is 4. So here what we are going to do is, we are going to cross multiply. If you cross multiply 3 and k, 3 into k will become 3k, 2 into 4 will become 8. In between it is not equal to, so let's maintain the same thing, 3k not equal to 8. So if you get transpose k 3 to other side, it will become k not equal to 8 by 3. This says that you should not give the value of k as 8 by 3. Okay, you should not give k as 8 by 3. Except this value, you can give any other value. I'm sorry. Except this value, that is 8 by 3. Other than this, you can give any other value. Okay, your wish, any value. Okay. So that will give you unique solution. So the question here is, what is the value of k so that the pair has unique solution? Here we have, what we have got is, k should not be equal to 8 by 3. Other than this, you can give any other value. so that the pair will have unique solution. Similarly, we have taken another question, 4x minus 3y equal to 5, 3x plus ky minus 2 equal to 0. And if you observe properly, here the constant term is in the RHS, but in the second one, it is in the LHS. Make sure both are on the same side. Okay. So I have sent this minus 2 to the other side. Now, if you observe both are on the same side, find A1, B1, C1, A2, B2, C2. And since the pair has unique solution, what is the condition for unique solution? A1 by A2 is not equal to B1 by B2. Take that, substitute the values, cross multiply. What we have got is K not equal to 9 by minus 4. Meaning, except this value, except K equal to minus 9 by 4, any other values for K can be given. Okay. So let's solve some more problems. See, this pair had unique solution. Even this pair has unique solution. It is already given in the question that this pair is having unique solution. If this pair is having unique solution, what is the value of K? That's what we have found. Let's take another pair which has no solution. Okay, and let's find the value of K. Okay. So here, again, we have taken a pair of linear equation, kx plus 3y equals k minus 2, 12x plus ky is equal to k. Okay. Here, this pair is having no solution. It is given that the pair is having no solution. If the pair is having no solution, then find the value of k. As usual, find a1, b1, c1, a2, b2, c2. So what is a1? Coefficient of x, that is k. What is b1? Coefficient of y, that is 3. What is c1? The constant term, that is a number or anything that is without any variable. Okay, here if you observe this k minus 2, this entire thing is considered to be c1. Okay, because there is no variable multiplied to it, isn't it? Similarly, a2 is 12, b2 is k, and c2 is also k. I hope it is clear. So we found a1, b1, c1, a2, b2, c2. That's what we have found. Okay. So as you can see, since the pair has no solution, what is the condition for no solution? A1 by A2 is equal to B1 by B2, but not equal to C1 by C2, isn't it? That is the condition. So we have taken that condition. Using this condition, substitute the values. A1 value is K, A2 value is 12, B1 value is 3, B2 value is K. Substitute all the values. Okay. Now here, we'll take this as equation 1. This will take it as equation 1. Okay. Here we are going to take any two that we wish. The first two or the next two. It's our wish. There are three things here. K by 12 is equal to 3 by K is equal to K minus 2 by K. It's our wish. Let's take anything, any two things. Okay. Let me take the first two things itself. Okay. K by 12 is equal to 3 by K. I've taken in the next line. Then I'm going to cross multiply. If I cross multiply K into K, K square, 12 into 3 will become 6. That's what we have done. Okay. So K square is equal to 36 implies K will become plus or minus, isn't it? K is equal to plus or minus root 36. Root 36 is 6. Therefore, we have got two values of K. One is positive 6. The other one is negative 6. So K value is either 6 or minus 6. Okay. But here, remember, we found the value of K using only these two things, isn't it? We took only the first two ratios and we found the value of K. So here we have got two values of K, 6 and minus 6. Remember that value that we have got should also satisfy the third condition that is there, isn't it? We didn't find the value of K using this. We didn't use this at all. But the value that we have got should satisfy all the three. So therefore, what I'm going to do is I'm going to substitute this in equation 1 and check whether it is going to satisfy all the three. Okay. Sometimes what happens is you will get values of K. Okay. But this values of K might not satisfy all the three. Okay. What we have got is going to satisfy only the first two. Okay. Here it was 12. I'm sorry. Because we found the value of K using only these two things, isn't it? Therefore, the value of K that we have got is going to satisfy the first one and the second one. But we don't know whether it's going to satisfy the third one because we didn't get this into the picture at all. We never use this. Therefore, as soon as you find the value of K, you have to verify it. So how do you verify it? Substitute in the equation 1. Okay. So as I have done here, substituting k is equal to 6 in equation 1. So this is my equation 1. I'm just rewriting this. This is my equation 1. We have rewritten it. So wherever k is there, substitute 6. Okay. First I'm checking for positive 6. So wherever k is there, I'm substituting as 6. Okay. If you observe, what is the condition? The condition says the first two ratios should be equal. A1 by A2, B1 by A2 should be equal. The last one, C1 by C2, should not be equal to the other two. Isn't it? Excuse me. As you can see, I've substituted k value as 6 by 12. So 6 ones are 6, 6 twos are 12. Again, 3 ones are 6, 3 twos are 6. 6 minus 2 is 4. 2 twos are 4, 2 threes are 6. As you can see, the first two are equal and it is not equal to the last one. This was our required condition, isn't it? The first two should be equal, but these two should not be equal to the last one. That was our condition. So k is equal to 6 is satisfying that condition. Therefore, k is equal to 6 is correct value. Okay. Let's also check for minus 6. So again, take equation 1. Wherever k is there, substitute it. So as soon as you substitute, so 6 ones are 6 twos are, 3 ones are 3 twos are, minus 8 by minus 6. So you get 4 by 3. As you can see, the first two are equal, but it is not equal to the third one. So here, both the values are satisfying the given equation or given condition. Therefore, the correct value of k is plus 6 as well as minus 6. Remember, sometimes what happens is, out of the two values, any one value might not satisfy. Okay, let's take another problem. One more problem. There we'll understand much more better. Okay, you can see you will get two values of k, but one will satisfy, the other one will not satisfy. Let's look into that. So sometimes even this happens. Okay, you will get two values of k, but both the values of k will not satisfy. That is also a possibility. Okay, so remember, as soon as you find the value of k, you must substitute back and check whether it is satisfying the condition. If it is satisfying the condition, then the value of k is considered the answer or the solution. Otherwise, if it is not satisfying, then we don't take that value. Okay, let's see one more problem to understand this much better. Okay, I've taken one more pair of linear equation, but here the condition that I've taken is infinite solution. Okay, the previous one was no solution, but here I've taken the condition as infinite solution. This pair is having infinite solution, so we have to find the value of k. So as usual, find the value of a1, b1, c1, a2, b2, c2. As you can see, a1 is k, a2 is, sorry, a1 is k, b1 is 3, c1 is k minus 3. Similarly, a2 is 12, b2 is k, and c2 is k. So we have found the value of a1, b1, c1, a2, b2, c2. Okay. Now, since the pair is having infinite solution, what is the condition? A1 by A2 is equal to B1 by B2, which is equal to C1 by C2. Substitute all the values. So as you can see, I've substituted A1, A2, B1, B2, C1, C2. Out of this, I'm going to take the first two. Okay. Let me take the first two and cross multiply. Once you cross multiply, you get k square is equal to 36. Therefore, k is equal to plus or minus 6. Again, here we have got two values. Remember, whether two values or any value, even if you get one value, you have to check. Okay, because why should we check? Because we got the value of k using only these two. We didn't take the third one into picture at all. But the value of k should satisfy all the three, isn't it? So therefore, whatever the value of k that you get, you should check it for both. In the sense, you have to put back in the equation one, you have to check it. Okay. Now, let's substitute k is equal to 6 in equation 1. So this is our equation 1. So let's substitute wherever k is there, put 6. So as you can see, 6 ones are 6, 6 twos are, 3 ones are 6, 3 twos are, 6 minus 3 is 3. 3 by 6 will become 1 by 2. As you can see, 1 by 2 is equal to 1 by 2 is equal to 1 by 2. What was our condition? Our condition was all the three must be equal, isn't it? A1 by A2, B1 by B2, C1 by C2. All the three must be equal. And here also, when you put the value of k as 6, all the three are equal. Therefore, k is equal to 6 is correct. It's a correct value. Now, let's find it for k is equal to minus 6. So, again in the equation, wherever k is there, I've substituted minus 6. As you can see, minus 6 by 12, 3 by k. So it will become 3 by minus 6, k minus 3. K is minus 6. So minus 6 minus 3 divided by k. K is what? Minus 6. So I have substituted. As you can see, 6 ones are 6 twos are, 3 ones are 3 twos are. Minus 6 minus 3 is minus 9 divided by minus 6. Minus minus gets cancelled. 3 threes are 3 twos are. Now you can observe that the first two are equal. Minus 1 by 2 minus 1 by 2 are equal. But it is not equal to the last one, isn't it? But what is our condition? All the three ratios must be equal. That is our condition. But here the value k is equal to minus 6 is satisfying only the first two, but it is not equal to the last one. Therefore, k is equal to minus 6 is not the correct value. Why is it not correct value? Because we found the value of k using only these two. So it is going to satisfy only these two. It's not going to satisfy the third one. Okay. Sometimes this is what happens, as I told you. Okay. So out of two values, one value is satisfying the condition, but the other value of k is not satisfying the condition. Therefore, the final answer of k is 6. This will be a final answer. So k is equal to minus 6. K is equal to minus 6 is not the value of k. Okay. Sometimes this also happens. K is equal to 6 and k is equal to minus 6. Both are not the correct value. This is also a possibility. Remember. Okay. So we have done three different types of problems. That is, if a pair has unique solution, how to find the value of k. If the pair has no solution and infinite solution, how to find the value of k. Okay. So this checking whether the k value is correct or wrong happens only in no solution and infinite solution. Okay. Because there are three conditions, three ratios. But in unique solution, we take only two ratios. A1 by A2 is not equal to B1 by 2. Therefore, no problem there. But in infinite solution and no solution, you will get, once you get the values, any number of values, one value or two value, or any number of values of k that you get, you have to substitute back and check whether it is satisfying all the three. If it is satisfying all the three, then you will take that as the correct answer. Otherwise, we don't take that as the correct answer. Okay, students. So far we have seen what is a solution, what type of solutions for a pair of linear equation do we get, and the conditions for solvability. Now we are going to start with the very important concept of this chapter, that is finding the solution. Okay. So far we were discussing what type of solution do we get. Okay. Now let's understand how to find the solution. Okay. Sometimes it is not, sometimes many a times it is not easy to find the solution. For example, if I give this question, 2x plus y is equal to 5 and 3x plus 2y is equal to 6. Now what I have to do is I have to find the value of x and y. This x and y should be in such a way that it should satisfy the first equation as well as the second equation. Okay. That is not very easy. Okay. So we need some methods to solve this. Okay. So totally there are 4 methods. Okay. There are 4 methods to solve. That is to find the solution. The 4 methods are substitution method. Okay. Substitution method, elimination method, cross multiplication method, and graphical method. Okay. There are 4 different methods. Okay. We'll learn one by one. And from the exam point of view, for state board students, elimination method, cross multiplication method, and graphical method are very, very important. Graphical method, 1000% you're going to get a question for 4 marks. Okay. Out of this elimination and cross multiplication, any one might come for 2 marks. Okay. Either this or this. Any one might come. Okay. So let's start with substitution method. What we'll do is we'll make a separate video on substitution method itself. Each method, substitution method a different video, elimination method a different video. That will be very nice and it will be easy to access also. So let me continue the substitution method in the next video. Thank you, students.